Good day, everyone. Today, we'll explore four fascinating concepts in physics: waves, light, electricity, and magnetism. Though they may seem different, these topics are deeply connected. From music and colors to cell phones and power plants. Let's start with waves. A wave is a disturbance that transfers energy from one point to another without the transfer of matter. There are two main types of waves. Mechanical waves, like sound and water waves, need a medium to travel through. Electromagnetic waves, like light, radio waves, and X-rays, can travel through empty space. Waves have important properties. First is amplitude. To measure how tall the wave is, related to energy. Next is wavelength. Wavelength is the distance between two peaks. Next is frequency. To know how many waves pass a point per second. And speed. It's how fast the wave travels. One everyday example is sound. When you speak, your vocal cords create vibrations in the air, which travel as sound waves to another person's ears. Now let's talk about light. Light is a type of electromagnetic wave, and unlike sound, it doesn't need a medium to travel. Light behaves both like a wave and a particle. This is known as wave-particle duality. As a wave, it shows properties like reflection, refraction, diffraction, and interference. As a particle, it comes in tiny packets of energy called photons. We only see a small part of the electromagnetic spectrum, the visible light. But there are many other types, including infrared, used in remotes, ultraviolet from the sun, X-rays for medical imaging, radio waves used in communication. Light also travels at an incredible speed, approximately 300,000 kilometers per second in a vacuum. Next is electricity. It is the movement of electrons, the tiny particles in atoms. There are two types of electricity: static electricity and current electricity. Static electricity is like when you rub a balloon on your hair and it sticks. Current electricity, which flows through wires and powers our homes and devices. Current electricity comes in two forms: direct current and alternating current. Direct current is when electrons flow in one direction, used in batteries. Alternating current is when electrons switch directions rapidly. Electricity follows certain rules. Electricity is what lights our homes, charges our phones, and runs machines, making it one of the most essential forms of energy today. And finally, let's talk about magnetism. Magnetism is a force caused by the movement of electric charges. It's most visible in magnets. Magnets have two poles, the north and the south poles. But here's the interesting part. Electricity and magnetism are connected. When an electric current flows through a wire, it creates a magnetic field around it. This is the principle behind electromagnets and many electric motors. This connection forms the basis of electromagnetism, one of the fundamental forces of nature. It powers generators, electric fans, and even the MRI machines in hospitals. So, in summary, waves transfer energy through vibrations. Light is an electromagnetic wave that lets us see the world. Electricity is the flow of electrons that powers technology. And magnetism is the force of attraction caused by electric charges in motion. Thank you, and I hope you learned something new today.